everybody, my name is Nate Kinsey, and I'm an assistant professor here in electrical and computer engineering at Virginia Commonwealth University. It's my pleasure to tell you a little bit about some of the research that we're doing here in our lab at VCU. At K-Lab Photonics here, we're fascinated by light. And one of the things that we like to do is try to find ways that we can use light to make life better for everyone. We have a couple ways that we do that. The first thing is we like to try to use theory and simulations to hone our ideas and to make better devices. So as you've seen before in the screenshots that we've taken, we use these simulations and software tools to actually design different devices and optimize their performance for different applications of interest that we're trying to accomplish. So for example, some of the projects that we work on here are trying to create different types of light sources to make communications more secure using quantum photonics.
I'm Sampriti, and currently I am studying under the doctoral program of Virginia Commonwealth University. My major is on electrical engineering, and my focus is to work with lights, which is called optics and photonics. I'm passionate about light, and it's a major branch of electrical engineering. Here our group's focus is to work with photonics, and it means we basically works with light. So light has the power, and with that we can control various on-chip devices. In particularly my project, we are working to implement such a device so that it could be used in quantum optics related applications.
The next step that we use in some of our tools is to actually fabricate the devices. So in many cases we'll go into the clean room and we'll use nanofabrication techniques where we can actually fabricate photonic devices on a size scale much smaller than light, on the order of a few to 100 atoms in size. So we can grow new materials, we can fabricate different devices and build them up from the ground up to do interesting things. One of the ways that we use to do this in our group is to explore things like metamaterials. Metamaterials are a concept of man-made materials that we can engineer at the nanoscale level to have very unique and interesting optical properties. For example, doing things like optical cloaking, as well as negative refractive index, properties that don't naturally exist in nature. So maybe someday soon Harry Potter's invisibility cloak might be real. One of the applications is in trying to make the internet faster. So in today's world with coronavirus and all of these things, telework and communication over digital platforms is very, very important and essential to what we do every day, even learning through school. And what could we do if we could make the internet even faster? What could we do if we could make the internet even more powerful? Our technologies are trying to do that. We develop better materials, better devices at the nanoscale level using the new nanotechnologies that have come along in the last 10 years. And we use that to try to improve the performance of the internet itself. So the next thing that we do after we fabricate some of these devices is we come into the optics lab here and we test these devices. Using our laser and different types of optical components that we have in the lab, we can take our materials and we can take our devices and we can shine them with different types of light. Perhaps in free space using a laser beam like out of a laser pointer, or through optical fiber, a piece of glass that's about the size of a hair. And we can use that to illuminate different types of devices and test their performance, understand their optical properties, and optimize them for many of the applications.
Hello, my name is Ray Secondo. I'm in my 4th year working on my Ph.D. in electrical engineering here at VCU, and I very much enjoy looking into the physics of how light works, especially at strong amounts of light, more than the sun can produce in our outdoor areas.
Hi, I'm Adam Ball. I'm a first-year PhD student here at VCU in the College of Engineering, working on my electrical engineering PhD degree, and I also really enjoy light. I enjoy computers, and I enjoy the interaction of the two.
In our group, we like to look at materials and how to make them better for optimized work in any function. And one of the ways that we can do that is by illuminating them with a strong amount of light and seeing what happens.
So this is what the results of the experimental setup would look like. This is how we would interpret the results and get the data that we want from the materials we have. For example, I can move the light or the glass slide here, and it will move the detector spot on the camera over here. So as I move it back and forth, the blue circle will move back and forth here. And this is how we interpret our results of hitting these materials with strong light.
So as you've taken a tour around the optical lab and around some of the different things that we've done, I hope that you get a sense of what we do here at K-Lab Photonics and why it's important and relevant to you. But beyond the things that we do, optics is very, very important in society in general. I can ask you to think about, what would your life be like without optics? Imagine a day where there's no light, it's darkness outside, there's no TV, there's no cell phone, there's no internet, right? There are no watches, smart watches. All of these things rely on optical technologies. Our life would be very, very, very different without light. Light is something that affects every facet of what we do in society and technology today. And in the end, our goal is to try to use light to make lives better for people. I hope you come join us.